हाय एवरीवन, कैसे हैं आप सभी लोग। आई होप यू आर डूइंग ग्रेट। और आपके ओवरवेलमिंग रिस्पांस के बाद ऑन द वीडियो फॉर रोड मैप टू न्यूक्लियर फिजिक्स एंड पार्टिकल फिजिक्स रिसर्च इन जनरल, मैं ये वीडियो बना रहा हूँ। एंड गिवन आई हैव अ बैकग्राउंड इन न्यूक्लियर एंड पार्टिकल फिजिक्स, आई थिंक आई हैव सम एडवाइस टू गिव टू यू विच एट द एंड ऑफ द day is going to be quite important for you if you want a realistic approach on how to pursue research in this, I would say, not a highly competitive field, but ये एक specialization है, unlike just like any other field. ऐसा नहीं है कि it's very overblown. The idea is that how to get into this as an Indian student, either in India or outside India. अगर आपको किसी research facility such as GSI या CERN या GANIL में जाना है, तो कैसे आप जा सकते हो? What could you possibly do, right? So given that I'm here, I have some information for you which you will find useful, and I think I should have asked for these questions myself when I was at your stage. तो ये जो सवाल हैं आपके, उनके आज जो जवाब हैं वो मैं लेके आया हूँ. सो आई होप यू विल वॉच द वीडियो टिल द वेरी एंड, बिकॉज देयर विल बी सम इम्पॉर्टेंट डिटेल्स आई विल बी डिस्कसिंग विच आई थिंक वुड हैव बीन वेरी इंपॉर्टेंट एडिशन टू माई अंडरस्टैंडिंग अगर मैंने अपने टाइम पर ये कहीं इन्फॉर्मेशन मिल गई होती ऑन द इंटरनेट. सो विदाउट फर्दर अडू लेट्स स्टार्ट दिस वीडियो. लेकिन एक छोटा सा डिस्क्लेमर यही है कि इसमें जो भी इंफॉर्मेशन है इज़ नॉट वेरी जनरल, इट्स स्लाइटली पर्सनलाइज्ड टू माई स्टोरी एंड माई एक्सपीरियंसेस. तो इसमें से जितनी चीज़ें आप ले सकते हो ले लीजिएगा. इसके बाद भी कुछ सवाल बचते हैं, यू कैन ऑलवेज आस्क. लेकिन एक जनरल डिस्क्रिप्शन में इस फील्ड का ज़रूर देने वाला हूँ. सो लेट्स गेट स्टार्टेड राइट अवे. ओके, सो एक छोटी सी चीज़ मैं बता देता हूँ दैट टुडेज वीडियो इज़ नॉट गोइंग टू बी ऑन ए प्रेजेंटेशन और एनीथिंग लाइक दैट. मैं सिर्फ बात करूँगा, आप सुन सकते हैं. तो और चाहे तो वीडियो को 1.25 पर भी चला सकते हैं इफ़ यू थिंक दैट आई एम टू स्लो फॉर योर पेस. आज का टाइम ही ऐसा हो गया, पीपल हैव शॉर्ट अटेंशन स्पैन. नेवरदलेस, सो लेट्स टॉक अबाउट न्यूक्लियर फिजिक्स और पार्टिकल फिजिक्स. टू बी स्पेसिफिक, ये क्या फील्ड है ये तो आपको पता ही होगा थोड़ा बहुत आइडिया. अगर नहीं है तो मैं बता देता हूँ. हियर पीपल like myself and several other scientists, either theoretically or experimentally, and at the conjunction of both of these fields, study fundamental forces of nature, fundamental particles which create you and me. They form matter and antimatter, of course. Also, I should not say of course, but yes, we do have antimatter also in the universe, and we are able to transport it. आपने CERN की न्यूज़ देखी होगी कि CERN में antimatter factory में उन्होंने transport किया था antimatter को in one of these magnetic chambers sort of container. So there is some very exciting research that goes on in this field, and I'm pretty sure आपको ये information तो पता ही होगी that the World Wide Web, यानी कि WWW, is a product of one of the researchers in this field. And interestingly, I have his book right here, which is this book by Tim Berners-Lee. So it was just lying around, तो मैंने impromptu दिखा दी. That he, working at CERN, was able to develop the internet or the protocol for internet and so on, along with several other people or scientists there. Some very exciting work goes on in particle physics and nuclear physics. If I give you an example, JSI में 6 nuclear elements discover हुए थे. I mean, you can look that up on the website, what are the exact names and so on. जिसमें से एक Darmstadtium है, Hassium है, and so on. So this is where, at the forefront of science, or at least in nuclear physics and particle physics, some exciting research goes on, and people are able to either discover new elements. जैसे अभी recently news आई थी कि कोई एक नया was a charm particle, I'm slightly forgetting, CERN में discover हुआ है, which has a charm quark inside. It's a heavy last living branch of the proton tree, as you call it. अगर आपको चाहिए तो इस पे एक separate video बना सकता हूँ. I was very gradually following the news. So some very exciting work goes on here is the motto, is the message I'm trying to get to you. Not to give you too much jargon in the field, but you understand the point. और ये वही field है research का where particles have very low mass, or well, slightly very low mass, and they have very high energy. So high energy nuclear physics or high energy particle physics or even low energy nuclear physics is still at the scale of couple hundred MeVs or few GeVs. GeVs is what you can let me know in the comments. That would be nice to know. So that is what more or less the idea is. Of course, इसको summarize ऐसे तो करना बहुत ही injustice sort of हो गया है, but I think a very brief introduction was required, so I gave you that. Okay, so how would you enter in this field, right? तो आप अगर physics background से हो, chemistry background से हो, maths से हो, theoretical physics से हो, या आपने engineering की है, तो आप particle physics, nuclear physics में कैसे घुस सकते हो. The idea is that first of all, you have to do an undergrad in pure sciences or engineering. Once you do that, either in physics or BTech or anything like that, BSMS, then usme aap internships कीजिए, of course, right? But I would suggest the following. You have to, of course, do internships, but you would not always find that you have the right opportunity to do internship in the exact same field. So उसके आसपास की opportunities मिल जाती हैं कई बार. My recommendation right away would be to get familiarized with coding. Either you take Python or you take C++, and that is very, very crucial. If you don't do that, you are going to have a hard time, right? चाहे आप theoretically काम कर रहे हो या experimentally. Especially experimentation में तो data analysis है ही. We do a lot of data analysis, we do the experiments, we get the data, and we spend a hefty amount of time analyzing what we get. But the problem is, in India, we don't really have detector facilities such as we have at CERN or GSI or GANIL, for example, or in Michigan State. So this is one thing. We do have facilities in India such as VECC is a good example. IUAC, जिस पे मैंने वीडियो बनाया था, आप जाके देख सकते हो. And we have independent labs and groups in different institutes in such as IITs or ISERs, which actively work on detector, manufacturing. I should not say manufacturing, but detector development and research and analysis and simulation work and theoretical work. So they do work in all these different areas, and they combine them, and they are in collaboration with groups from all over the world. तो exposure wise आप कोई भी काम करोगे, आपको कोई भी प्रॉब्लम नहीं होगी. ऐसा मैं नहीं बोलूँगा, because होगी. I faced a lot of problem when I was working with one of the groups. शुरुआत में तो मुझे चीज़ें समझ ही नहीं आ रही थी, and that was a big problem, right? And that was when I realized a good peer group or a good, surrounding or colleagues are very important. So I would not say that, when you come to institutes outside India, it's the best thing in the world. Everything has its pros and cons, but the idea is things are slightly more progressive when it comes to either administrative stuff or when it comes to scientific pursuits and questions like that. Things are more progressive and more work oriented rather than problem oriented, or problems in work oriented, which is a good thing. तो उसको चलो आप समझ गए that there is something like that. So better to aim for opportunities outside India. But let's say you are a first year student, तो आप क्या करोगे? Again, get used to a programming language. Python, C++, pick your poison and get started. Once you do that, then I would very highly recommend you that you get familiarized with Linux systems, or, Ubuntu, for example, or Mint, or whatever is comfortable to you. You get used to one of these systems. Don't work on Windows. It's a piece of shit for analysis work mostly. Mind my language. It's not a piece of shit in general sense. It's an okay operating system. मेरी भाषा को बहुत seriously मत लेना. I'm just in a light mood. But the idea is you have to use Ubuntu and Linux systems, mostly everything that you will do for analysis, either in theory or experimental side. So this is one. You have to familiarize yourself in the first year. लेकिन आप second year में आए, or you are transitioning from, already learning these things, then what do? Then of course you have to do something called reading, right? So you have to learn physics, and that's very underrated, because some people just think कि मैं group में काम कर लूंगा and I will learn everything. Impossible, because nobody has the time, in fact, to supervise you at every instance. So that's where you have to use your own brain. That's where you have to sit down, read, learn, and you have to really work hard on this. चाहे आप quantum mechanics पढ़ रहे हो, nuclear physics पढ़ रहे हो, particle physics, या फिर introduction to quantum field theory, quantum electrodynamics, or anything in general that you are reading, you have to first learn how to read. If you don't do that, you will start struggling. And that is where you will start losing your interest. That's the most easy breaking point. So first of all, learn to read. Once you learn that, then you start reading research papers, which I will tell you, even today I find hard to do, because research papers are hard to read. तो उसके लिए क्या करना चाहिए? पढ़ो papers को, but don't read them linearly. Don't go from abstract and then all the way till the conclusion. Do it in a non-linear fashion. You have to go between references at some point, and then you have to keep reading, and then you have to, do something by yourself to understand what they've done. So it's a crazy business, and that's how science works. things are not supposed to be easy, and you better learn that as soon as possible. And this is not just applicable to nuclear physics or particle physics. This is in general anywhere in science, right? It's not supposed to be easy. So this is just a very small reality check. I know this video is not specifically intended for reality checks, but this is something I want you to know कि आप ऐसे फील्ड में स्टेप इन कर रहे हो जहाँ पे चीज़ें बहुत इतनी ईजी नहीं होने वाली. इट इज़ नॉट गोइंग टू बी लाइक रीडिंग सम lecture notes from some class or whatever course you take in your institute or college, because हमको उसी की आदत होती है. As students from India, we are very used to spoon feeding business, which you will suffer through when you come to any place like outside India or in a group which has people from different countries, different regions, different expertise, and all of them are very good in something or the other, and you are used to one linear way of doing things. I struggled a lot, honestly, and that was a good kind of struggle because it made me realize many things which I thought I kind of knew, but then I realized I did not know. So it turns out what you would do, right? So आप सेकेंड ईयर में आ गए, आपने थ्योरी भी पढ़ ली, आपने पेपर्स कैसे पढ़ते हैं उसका भी थोड़ा आइडिया लगा लिया. Then it turns to what you should do to be able to land a position somewhere. The idea is that you keep working in the field that you're interested in. If you're interested with detectors or analysis, you keep doing that. And then eventually, when you keep these internships in your CV as you go in your academic journey, you keep working with faculties in your institute because you have to keep associating with people who are working in these things, and you keep attending conferences and workshops and talks. And the more you put your head into this field, the more you realize there are things that you don't know. तो उसमें क्या करेंगे, तो आपको चीज़ें सीखने के लिए फिर से पढ़ना पड़ेगा. So you have to read a lot, of course. You have to learn a lot, of course. You have to get familiarized with tools such as Root, C++, or Python, and Unix or Linux based systems. You can also use MacBook if you are comfortable with that. And then, of course, you have to learn to read papers, and then you have to sort of develop this understanding of how experiments work, which for the very long time I had no idea. ठीक है, यहाँ आने के बाद मुझे पता चला कि चीज़ें इतनी ईजी नहीं है when it comes to experimental analysis or data analysis. It's very hard to do things and it's slow. So you have to realize that if you take an internship project, it might not be the project for 3 months that you think you would be able to publish something. Maybe you will have some small contribution that goes into a publication, but an independent research or an independent project for analysis or something like that, or theoretical also, will not be sufficing for 3 month project. तो आपको उसके लिए 1 साल लगेगा at most, or at minimum, I would say. So keep in mind that yes, you could get some small publication here or there, second author, third author. First author would be quite hard and it takes time, and nothing to feel disappointed by. लोगों के सेकंड थर्ड ईयर पीएचडी में भी कोई पब्लिकेशन नहीं होते, कोलैबोरेटिव होते हैं, ऑफ कोर्स. सो दिस इज समथिंग यू शुड नो. ओके, सो आई टेल यू वेरी vague stuff now, but what to do to become a nuclear physicist or particle physicist? Nothing, basically. You keep working in this field and eventually you land at a position in PhD or masters, and then you keep working in this field, and then one day you start calling yourself nuclear or particle physicist. Now that's a very bad answer, but that's the truth. So there is nothing you have to do to become this person, right? You just have to keep working in this field, and एक दिन आप अपने आप को particle physicist या nuclear physicist बुलाने लगोगे, or that would be the day other people will also call you that, and then one day you become a doctor, like a doctorate, like PhD, and then you will officially call yourself a scientist in that field with specialization in so and so niche. तो ये लंबा रास्ता जो है इससे आप जाएंगे, और जो मेन चीज़ें हैं जिनका आपको ध्यान रखना है इज टू रीड एंड टू वर्क ड्यूरिंग इंटर्नशिप्स, to do as many projects as you can, to be as dynamic as you can, and be as flexible as you can. Because if you stick कि मुझे तो यही करना है, ये नहीं करूँगा तो कुछ नहीं करूँगा, then trust me, कुछ नहीं करोगे, and you will be nowhere. So you have to learn to be a little flexible. I don't mean to say कि particle physics में interest था तो सीधा condensed matter में घुस गए. Maybe in the long run, 10-15 years, you make a very subtle shift in your field of research, but that's when you have a specialization and you have a group that you either lead or work in. तो वहाँ पे जो करना है करो, but at this point where you're trying to build a path into one of this very competitive, highly skilled field where you really need to be comfortable with coding and experimental vision and reading papers, which in general in science you have to do everywhere. But ये जो field है physics का needs you to be very good in several parts of physics. You also have to have some understanding of quantum mechanics, some mostly nuclear physics and particle physics, which comes after quantum mechanics, and maybe some electrodynamics, quantum electrodynamics, field theories, right? So I would not say other stuff other than that. Of course, special relativity वगैरह तो आना ही चाहिए, comfortable होने ही चाहिए, because you will be working with relativistic systems mostly, of course, always. तो ये चीज़ें अगर आप नहीं अपने दिनचर्या में डालेंगे, then at the end of 5 years or 4 years, when you start this, that's when all this burden will fall on your, very soft shoulders, and you will fall down, and then it will take a lot of momentum to get started. So what do? You start today. Whenever today is for you, you start today. जब भी आप ये वीडियो देख रहे हैं and you're interested in this field, I'm guessing that is the only reason why you're watching this video. You start, and then you do it. And then when you do it, you let me know or anybody from our team, and then we will tell you congratulations. And then you keep working in this field, and then one fine day you make it, and then that would be the day we would happily call you colleagues, or I would call you colleague, right? तो इस वेग से वीडियो के बाद मेरा आपको यही मैसेज है that if you have taken this decision that you want to enter this crazy field of subatomic systems, many body quantum systems which do crazy stuff, have very crazy, reactions, and possibly don't even exist. So we synthesize them in laboratories where we collide them at unimaginable energies at very small lengths, say scales. Okay, welcome. And I hope you enjoy this. But if you don't make this choice, all the very best for whatever you do. I'm pretty sure you will enjoy that and this as well. So, okay. मैंने बहुत इधर उधर की बातें कर दी, और ये वीडियो बहुत लाइट सेंस में लिया था मैंने, बिकॉज आई डोंट वांट टू हर्डल यू विद दिस, ये कर लो, वो कर लो, ये पढ़ लो, वो पढ़ लो, ऐसे करना है, वैसे करना है. No. You do it the way you want to do it, and then you figure it out along the path. And I think that is one of the best ways to enter this field, because there are not many projects that are like very ongoing, especially in India for a lot of students. Yes, they are mostly analysis work, and they are at a level where जो पेड़ है ना फिजिक्स का, उसके लास्ट ब्रांच पर आपको पहुंचना पड़ेगा, and that means you have to travel all the way from the stem or this whatever part of this body is called trunk, I think. फिर वहां से आप टहनी पे जाओगे, ब्रांच की लास्ट लीफ पे कहीं आपका एनालिसिस का काम है. वहां तक पहुंचने के लिए पूरा पेड़ चढ़ना is a very difficult task, and it is very exhaustive, and it's very lengthy, and to do that for the first time is going to break you. So better to start today and fall down, and then start again, and then fall down, and then start again, and then fall down, and then one day you build a ladder and then you reach there. So you will learn it, and I'm pretty sure jisko karna hai, they will figure it out. So if you have any more questions, ask them in the comments, and I would be more than happy to answer. But at this moment, I will stop because I'm really sweating. Germany में इतना गर्मी हो गया है. I've opened my window and my fan is like right here, and it's very hot. So I have to stop this video, and I think this is all the message that I have for you. But if you have any questions, comment section will always be open for you. Please ask your questions and I would be happy to answer. So I am Sagar here, signing off. I wish you all the very best if you enter this crazy field of subatomic systems and unimaginable forces and crazy data analysis. Happy to indulge you. So I will see you next time. Until then, signing off. Sagar here. All the very best. Bye.